Okay, guys, good morning, afternoon, if it's your birthday, happy birthday. Um, my name's Plain Wala. I'm from Babaji's classes and Babaji Flying School. Today, congratulations on reaching so far. Today, we are going to be doing air conditioning. Please see the first two videos if in case you just kind of skip them. The congratulations was for that. And, air conditioning is what we're doing today. The objective of today is to save your cash from you spending and going for some expensive classes. I'll be teaching you almost kind of the same level of knowledge that you're going to get out there. And yeah, extra knowledge is not going to kind of help you because 64 hours, what is anyone going to expect you to actually learn from the aircraft? 200 hours it took you for CPL. Anyways, going off topic, let's talk about today. I'm showing little snippets from the FCOM itself. You can see two images are very important for us, these two, and these two images is what I'm going to be explaining the entire air conditioning about. So you will understand that how important just the architecture itself is. Through the architecture you get to learn everything. Okay, controls and indicators is your homework, because it's a very dry subject. I don't like it myself. It's a lot of numbers and all, and I'm sorry about that. Okay, some of y'all will be referring to zone controllers. Zone controllers not used anymore. Everybody's using ACSCs. Okay, in case y'all don't know what those things are, when we come into the chapter itself, it'll kind of help y'all. Hopefully you guys have done your TR before. If not, it's also good because people who have done their TR also don't know what the hell is going on. Okay, so anyways, let's start. We have air conditioning. Okay, so air conditioning, there are two packs. Okay, you can imagine packs as pneumatic air conditioning kits. Okay, so the idea is pneumatic means you're using air. Okay, like how hydraulic you're using a fluid, like a liquid, you're using air. Okay, so in pneumatic you're using air to pressurize the aircraft. You'll be using it for ventilation later on. You'll be using it for your what do you call, controlling the temperature in the aircraft and everything. So we are the packs actually kind of provide the air which is going to be pressurizing, and you're going to be using it for your ventilation also. You're going to be using it for that same air in the end you're going to be using for even temperature. In short, it helps you kind of control the atmosphere inside the environment, inside the aircraft, sorry. Okay, the environment inside the aircraft also, you could say. Okay, so sorry, I just got a message, I was reading that. So the pack, now the pack is very simple. We have two packs. Why do we have two packs? One fails, the other one's there. Simple. Okay, redundancy. You try to remember why we have extra stuff. It's usually redundancy. In case one fails, the other one's there, and these two help each other in providing the required amount of air. Okay, so each pack has three sources. Okay, so you might be wondering here, oh shit, one pack only has one source out here. Okay, so sorry, I want to edit it. Can I? Oh. Okay, first time I'm using kind of paint and all for this, whatever this photos thing is. Can I put this down? Ah. So anyways, if you notice the packs, I had said they have three sources of air. So you'll say, no, the pack only is showing one line. Yeah, this is one line, but who's providing this one line basically is how do I change the size? Thank God. My God, hate Apple devices. Anyways, personal preference, Apple, please don't sue me. Anyways, three sources. You'll say, yeah, Jayan, there is only one line. So the idea is I'm getting kind of warnings and all. Okay, so the idea is that you have three sources of air. So the idea is you're using the same duct to add air into the system. So which three sources do we have? We have our engine bleeds, okay, we have our APU bleeds, okay, and we have a high pressure connection under the pack itself. You'll notice a very thin, because it's high pressure. High pressure means there's a lot of force hitting the, the circumference of that pipe. So it has to be a very small pipe, a very thick small pipe, because it's very high pressure it's provided. So this small pipe is attached, and it's much smaller compared to the low pressure pipes. Okay, the low pressure pipes are massive, big pipes which you usually see in the aircraft. Yellow color big pipes coming near the nose area of the aircraft. You'll see from there. Okay, so those are low pressure, but here we use a high pressure because the packs usually receive air bleed from the engine itself. Okay, so if it's coming from the engine, the engine is going to be having very high pressure, so you need to make this into low pressure, and then you air condition it and you get it to your temperature you want, and then you give it to the passengers and the systems whatever requires it for ventilation and everything. Okay, so far pretty good. Okay, three sources: APU, engine, HP, high pressure ground connection. Okay, so the pack processes this air and supplies cold conditioned air. Okay, so he'll take in high pressure air and he'll give out cold conditioned air. Okay, cold, little low pressure conditioned air. Okay, little lower pressure conditioned air. So it's good for the for everyone. Okay, now it provides it where, you'll ask. Okay, so it provides this air into something called a mixer unit. Okay, the mixer unit takes in air from the cabin itself. Okay, so if somebody's passed gas and kind of farted in the cockpit, not cockpit, sorry, we are in the cockpit, but in the cabin or something, that air is recirculating throughout the system. So this air will come in, okay, into the mixer unit. Some of the air is thrown out. It's not that air is not thrown out. Air is also thrown out. This air comes in from the cabin. You have air coming in from the packs also. In case you have a emergency ram air connection, here you see an emergency ram air. We'll come to this, don't worry. Otherwise, a low pressure ground connection, we'll also come to this. Low air pressure ground connection, these will all come to the mixer unit. So if you notice, the mixer unit always gets low pressure air. Okay, so low pressure air comes to the mixer unit. It's cool, nice air. It'll mix all the air together. Usually pack 1 supplies a large chunk of the cockpit air. Okay, pack 2 supplies a large chunk of the forward and aft air. Okay, the mixer unit does mixing, but it doesn't mix like everything through it. So later on when failures come up, you will notice that pack 1 usually supplies cockpit and pack 2 will be supplying forward and aft, but you will say, array, there is a mixer unit in the middle. Usually the mixer unit is not the mixer unit is not mixing everything together. It mixes like majority of the thing gets supplied by pack 1. Like pack 1 will supply majority of cockpit air, pack 2 will supply majority of the cabin air. Little mixing takes place in the middle. Okay, so later on you shouldn't get confused on that. Okay, so some hot air is extracted upstream. Okay, so if you see upstream, downstream, don't get confused. Downstream is when you go down this way. Okay, just because the thing is up in the diagram doesn't mean it's upstream. Okay, upstream is this. Okay, so how is the air flowing? You should see the flow of the air. So the air is flowing from here and then it goes through. So that's why upstream you have hot air. Okay, this hot air has been tapped upstream of the packs and it comes to this hot air pressure regulating valve. This valve will only regulate pressure. Okay, later on you will read the hot air pressure regulating valve and trim air valves control pressure and temperature. That's because both of them together will control. So the trim air valves, T for trim, T for temperature. The trim air valves control temperature. The hot air pressure regulating valve only controls pressure. Okay, we are done with this. So what it does, this is like fine tuning. So usually the packs will deliver the coldest selected temperature on your sorry selected temperature on your panel. Okay, okay, so whatever I select here, it will give me the coldest temperature, the packs, and then through this hot air pressure regulating valve and your trim air valves, it'll provide finesse and it'll give you your temperature, how much is required, okay, for each zone. Okay, I hope there's no confusion so far. If any confusion, please feel free to comment. Whenever I have time, I will reply. Okay. Otherwise, other people will also reply. You don't need to worry. Your solutions will be found. Okay, and you can make a fake account and ask anonymously also. Anyways, so we are done with pack flow controllers. Not pack flow controllers. Sorry, packs. We are done with the hot air. Okay. Now let's talk about. Okay. Hot air pressure regulating valves regulates pressure, trim air valves regulates temperature. We're done with that. There is a LP ground connection which is externally processed and sent directly to the three valves. Okay, so this LP ground connection, it's basically airport ka hawa na. You take the airport air and you shove it into the mixer unit, and then the mixer unit is already getting nice cool chilled air from the airport. Now you cannot control that. Okay, you cannot control the temperature because it's not coming into the packs. So this panel is not controlling what technically you're getting from the LP ground connection. That is being given by the maintenance guy outside. Okay, he is deciding what is the lowest temperature coming through, and he supplies it into the mixer unit. Okay, so in case they ask you, you cannot regulate the temperature of this air. Okay, anyways, it's sent directly to your three zones via the mixer unit. Then we have emergency ram air. Okay, what is this emergency ram air? In case you have any issue in flight, supposing my packs are gone, that doesn't mean I can't supply air to the passengers also need to, the point is survival in the end only, na. You need to get them alive to the destination. So how are you going to give them air to breathe? There is an emergency ram air. Emergency ram air is just at the bottom. Okay, now remember, later on you will see other ram airs also. Ram air is nothing, it's just air. There's like a flap. Okay, if this is the skin, there is a flap type of a thing, and this allows this is the nose of the aircraft. So like this is a cockpit. Okay, oh yeah, there is a diagram on top. Oh shit. Sorry. Okay, so supposing that's our aircraft. Okay, so we have a ram air like this one flap type thing in the center, and it just pops out. Okay, and then because the aircraft is flying, the air gets into the mixer unit, and this will supply air. So but again, you can't regulate that air as such. Okay, so it'll come in case both your packs have failed or you have smoke. Why you have smoke? The packs might be failed and the packs are supplying the smoke into the cockpit or the cabin. I keep on saying cockpit, in the cabin also. So the idea is you don't want smoke continuously pumping in, right? So the packs get switched off and you start pumping fresh air from outside, and the outflow valve will open. Okay, now the outflow valve will come into pressurization. That time you'll notice what is the outflow valve. That helps you pressurize. So because air is coming inside the aircraft, there has to be somewhere the air goes out also from, right? That is called the outflow valve. So the air comes in and it will come in through the emergency ram air, because you know that the smoke is not outside. You're getting fresh air from outside, and you throw it outboard and throw the smoke filled air outboard also through the outflow valve. Okay, we're done with this. Now both the packs give the lowest of the three selected temperatures, and hence the three trim air valves regulate the temperature of your zone. Okay, the HP is directly connected to the packs. Okay, the LP and HP cannot run simultaneously. The LP ground connection, HP ground connections cannot be run simultaneously. Okay, now the aircraft does not know when the HP is on. Okay, so the issue is कि if I have started the pack, okay, and I am supplying bleed air, okay, supposing I'm supplying any pneumatic air is called kind of bleed it's called. So bleed air, if I'm supplying from APU or I'm supplying from the engines, what is happening is the pack doesn't know that the HP ground has also been connected. So then the ducting can get spoiled, and the air, depending on whose pressure is more, the air will go into the that other side also, because it's all pressure dependent in the end. Okay, it depends on kiska flow is more. Okay, so now because the pack itself doesn't know ki, how much has been, who's been switched on, it'll have this issue. Okay, so HP ground connection, HP not LP, HP ground connection cannot be switched on with the APU bleed or the engines. Even LP cannot be switched on with these. Okay, it's just that the HP will cause a problem with your ducting, as in your APU bleed ka ducting or your engine bleed ka ducting also. Okay, I hope you all have not got confused out here. Okay, LP and HP don't run simultaneously. The aircraft, again I'm telling you, aircraft cannot detect LP and HP ground supply, thus it doesn't understand the difference between APU engine supply and the HP LP supply. Okay, so it can cause a problem with like reverse flows in different directions and all. Okay, so don't switch them on in the end, like with the other stuff. If the aircraft is producing it, then let the aircraft produce it and use the aircraft car. If the company SOP in the end will depend on, because some airports will be cheap, some airports will be expensive, depends. Okay, I'm going off topic, let's come back. Pack schematic. Okay, now how does this pack run will be your next question. Now remember this emergency ram air out here which I told you, this is an emergency ram air. The packs itself also have a ram air, so technically you have 3 ram air inlet flaps. Okay, okay, so how do I edit this? Edit answer, perfect. So now ram air inlet flap, again if the air has to come in, the air also has to go out. Okay, you'll notice out here. Okay, this is the ram air, this is not yet the pack ka main part. Okay, so now let me explain how this works. Okay, here you have a pack control flow valve. Okay, this pack control valve is what is that upstream I talked about, that air that is coming from your bleed, from your HP ground connection, from your engine bleed, APU bleed, those sources. Okay, that air comes in. That air must go through a primary heat exchanger. It is an air to air heat exchanger. So what it does, there is like a mesh. Okay, there's like a metal mesh like this, and air is passed through it. Now outside this metal mesh, there is air which is touching the mesh and going through it. Okay, so there is transfer of heat between air, but the air actually doesn't touch each other. There is a metal ka kind of like a barrier between them. So the metal helps distinguish between the flows, but it cools. Okay, there is a transfer of heat. So the primary heat exchanger goes through. Now once it goes through the primary heat exchanger, I'll explain how these heat exchangers also work. So once it goes through the primary heat exchanger, then it goes to something called a compressor. Now the compressor, because you need the air pressurized, okay, to your specifications. Right now when I've removed heat and all from it, the pressure also must have decreased and everything. So the compressor, because you need the air pressurized for your use also, compressor will compress this air, and compress means it'll dabao it, it'll squeeze it. So when the air gets squeezed, the air heats up. Okay, the air heats up. Now because the air heats up, it heats up so much that it must go through the, again like that heat exchanger, it must go through the heat exchanger twice because the air is very hot. Okay, so it goes through the heat exchanger twice. Okay, and then it comes to a turbine because something has to run this compressor. So this turbine that is there, it runs the compressor. Okay, now because you're running a turbine, further cooling of the air happens. Okay, now you'll notice there are a lot of temperature sensors. So this comes in your eCamca page. If you notice how much degrees Celsius you have. Okay, so if you notice later on when you do controls and indicators, you will notice that there is a general trend of your ranges to decrease. Okay, it'll generally be ki, okay, after compressor outlet ka temperature will have like 260, whereas pack outlet temperature will have 90 degrees, like that. Okay, you'll notice these things. Now how does the heat exchanger work? Heat exchanger is straightforward. I hope you all have understood so far. Heat exchanger takes ram air from outside, cold, cool air from the atmosphere. It touches this heat exchanger, this metal ka mesh, and then there is a cooling fan. The cooling fan is again connected to this compressor turbine ka connection, and it pumps out the air. So it gives you ventilation. That cooling fan is meant to give like a ventilation through the system. So air goes through it. Now this is a very effective system. Okay, imagine a fan which is continuously hitting something, so it'll cool it even if the temperature is outside hot. Because of the fan ka movement and air continuously moving through it, it'll cool the system. Okay, now we come to the purpose of this part of the thing, this bypass. Okay, what is all this? Okay, now supposing we have a compressor failure, अपना compressor ही खराब, turbine ही खराब. Okay, this connection out here na, this has broken. Okay, dogs are barking. So this compressor is broken. Now this compressor is broken. हवा कैसे चलेगा? Compress तो हो ही नहीं रहा. No problem. You still need to supply air, correct? It's better than no air. It's better than ram air. At least some air I'll be able to give, like little proper air. I'll be able to help the other pack. Okay. So idea is pass it through the first heat exchanger and provide little cooling, and then give that to the passengers. At least it is cooled air. It is little able to handle it. Okay. So air comes through. Okay, now some of the air does go through the compressor because the compressor has a little outlet type of a thing. So little air goes through the compressor. Okay, that little air gets cooled like twice more. It does run the turbine if it can. The turbine's not broken or anything. And then it goes down out of the pack. Okay, that's the normal way. Okay, because the compressor is broken and a little air is going through. Now our next thing is this bypass. What does the bypass work? So the idea is hot air does go through here. Okay, but it's very less hot air. Okay, it's very small tube. So hot air does go through it. Now this bypass is something like that trim valve which we saw earlier. Something similar. Purpose is kind of similar. So now the issue is, once it's gone through this heat exchanger, what they do is, usually they were using this bypass valve to maintain this temperature which was coming out. Okay, because it was hot air which they were taking from front. Okay, so now what they do is, now they realized that instead of just regulating the temperature exactly, what we do is we open the bypass valve fully. So at least air is going through the system. Okay, at least it's doing heat cooling method. Okay, and that's how they maintain the temperature in case there is a compressor failure. Okay, that is the major part of your what do you call air conditioning. Okay, now it's just now basic tweaks which I'll just tell you overall. Okay, what to do. So okay, so you have two ram air inlet flaps for both your one for each pack. Okay, so one pack has one ram air inlet, the other pack has the other ram air inlet. That's it. Okay, you have one emergency ram air inlet flap. So in total you have three ram air flaps. Okay, one is emergency and then one for each pack. Okay, now the air enters the pack via the pack flow control valve. The valve is pneumatically operated, electrically controlled. Absence of air pressure, it's spring loaded, it closes. Okay, the air enters the primary heat exchanger, okay, for initial cooling, and then is sent to the compressor. Okay, in the compressor the air is pressurized, which causes it to heat up and rise in temperature. Hence the air is then sent through the main heat exchanger twice. After this, the air is sent to the turbine where the energy is used to drive the turbine, and then further the compressor and then the cooling fan. The energy that is totally used by the turbine causes further cooling of your air. Okay, the cooling fan creates enough airflow suction for the ram air inlet ducts to supply air. This ensures that the exiting air is also not too hot to damage any ducts. Okay, so this cooling fan also helps prevent damaging of these ducts by sending too much hot air. They keep flow of air throughout. Okay, then there is only one emergency ram air but two ram air inlet flaps. Okay, hot air pressure regulating valve. Okay, now our next thing is the hot air pressure regulating valve. So the hot air pressure regulating valve is again everything out here na pneumatically operated, electrically controlled. What do you understand that by this? Pneumatically operated means it opens, closes pneumatically. Electrically controlled means finesse, like आराम से open it and close it electrically. Okay, kitna electrically control, you can control it, how much you want to push through. Okay. Anyways, it is pneumatically operated and electrically controlled. ACSC1 regulates this valve. Okay, ACSC1 regulates this valve. Okay, what is ACSC1? ACSC1 is Air Conditioning System Controller 1. ACSC1 basically is the guy who's giving commands to your pack and giving commands to your hot air pressure regulating valve. What commands is it giving? It's giving through your overhead panel, whatever commands you are asking from it. Okay, kitna temperature you have to give, how much flow of air do you want this pack on, do you want it off, all that information it's getting. Okay, it finds out everything it will find out, whatever you're requesting, it will kind of help it. Ram air is open or not, all that information is going. Okay, now it also controls, if you notice, because he's controlling everything, he is controlling even the pack flow control valve, he's controlling your hot air pressure regulating valve, he's controlling the pack ka opening closing of the ram air, kitna, how much the bypass valve is opening closing, all that. Okay, so ACSC1 controls the hot air pressure regulating valve. The hot air pressure regulating valve will also close. This also closes when your ACSC2 fails. This is because one pack can only supply so much of air. Okay, so if you're running on one pack, it won't be able to handle this supply of so much air that it will be able to handle the temperatures very well. Okay, so the idea is because you're on one pack supply and your trim air valves are also shut, there is a different logic which other people also do, two trim air valves shut because of an AC failure. That's why the hot air pressure regulating valve also closes. That is also true. Okay, the hot air pressure regulating valve has automatic closing, but it's also good to consider कि you're running on one pack only. ठीक है. Anyways, so here we go. When does the valve automatically close? It closes when both lanes. So again, the ACSC has two lanes. Two lanes means what? Basically, it has one set of kind of uh, electrical chip, you can say, and then it has another set of the electrical chip. In case one of the chips fail, it has, so two lanes they call it. Basically, think of it as like a backup system and a active system. So in case one lane fails, the other one will take over. If the other one fails, the other one will take over, like that. Okay, so if both the lanes fail, that means now the ACSC, both lanes have failed. It's not possible for the ACSC to run anymore because there are only two lanes that control it. So both the lanes have failed, the ACSC is shut, duct overheats. Okay, why will I supply hot air into the thing? It's overheating, yeah. So because it's overheating, it will automatically shut. So in case there is overheat, it notices that there is a overheat happening, it'll say okay, shut it. It might cause problems in the further of the duct. Okay, at least two trim air valves fail. Okay, so that's why when ACSC2 fails, people say ki ACSC2 has failed. ACSC2 fails. ACSC2 is actually controlling these two valves. Okay, so when ACSC2 fails, these two valves will shut, and because these two valves shut, hot air pressure regulating valve shuts. Okay, I should have actually taught that first. So if you notice, the ACSC1 controls only one. ACSC1 controls the cockpit trim air valve and the hot air pressure regulating valve. ACSC2 controls just the two trim air valves. Okay, sorry. Okay, now duct overheats, two trim air valves fail. Okay, now trim air valve failure. If trim air valve fails, they are electrically controlled by the ACSC anyways. It adjusts the temperature by adding hot air. Cockpit trim air valves are controlled by ACSC1, by ACSC2. Okay, the ACSC2 is forward and aft trim air valves. Okay, as such, for the trim air valve failure, you just lose regulation of the temperature. Okay, temperature regulation is lost. Okay, but the other sides ka it's not lost. Only that one guy will be lost. Anyways, then again, if you have two trim air valve failure, then the hot air pressure regulating valve itself shuts. Because the hot air pressure regulating valve shuts, all trim air valves shut. Because all trim air valves shut, there is no pressure regulation or temperature regulation then happening for that point. Like basically that there's no hot air now coming in. It's just like whatever the packs are supplying, that's what you're getting out there. Okay, so ram air inlet flap, it closes during takeoff and landing. Okay, the ram air inlet flaps, because it opens out in the open and it's supposed to take in air. What they do is to prevent any ingestion of material like gravel or anything going inside, hitting the compressor and breaking that compressor up, or hitting the turbine and breaking the turbine up. To prevent all of that, they close it during your takeoff and landing. So it closes when takeoff power is set and the main landing gear struts are compressed. Okay, and during landing, once you have landed, as soon as speeds are like your main landing gears are compressed, speeds are going below 70 knots, then what happens, main landing gears are compressed, speed is above 70 knots, it remains closed, it will open, speeds below 70 knots 20 seconds later. Okay, so that means I've landed the aircraft, my speeds have come to 70 knots. Now 20 seconds ka timer will start. After 20 seconds, the ram air inlet flap will open. Okay, hopefully you slow down by then. Otherwise, 20 seconds, 70 knots, do the math, see how much runway you have. uh, pack flow control valve. Okay, so now the pack flow control valve, it says low, norm, high. Now the trick part in papers are, these guys love their language. Okay, in low it will say 80% airflow. Okay, so it's 80, 100, 120% of airflow. Okay, now the trick these guys do is, we have passengers of 140 passengers on board. What would be the pack flow selection? Now everybody will go and say, passengers on board is 140, so pack flow selection is going to be low, because it says in the FCOM, it will say कि 141 occupants, below 141 occupants, then you can set it on low. It says occupants, it doesn't say passengers. Occupants includes flight crew, cabin crew, everybody on board. Okay, so if it says 140 passengers, you need to know how much cabin crew is also there, and obviously it's going to be higher than one person on board. Okay, so therefore you're going to always be on normal, you'll never be on low. Okay, then your next one, normal airflow, is just for normal operating cases, and high is done in case you have hot and humid conditions. So like Mumbai, it's hot, it's humid, put it on high. Okay, high conditions does not depend on passenger load. Now we have, whenever the APU has selected APU bleed, in that case you have to one second, I'm getting a lot of messages on WhatsApp. APU bleed is on, or we are on single pack operations, then we are on high flow no matter what. Okay, yeah. No, I'm seeing people complain about classes and all, so, and I'm making a video right now. Anyways, phew. Oh my god, yeah. Anyways, classes are a scam. Hey, yeah. See, I might be taking classes also, but tell me if y'all like kind of want discount. Say, saw your YouTube videos, a little discount. Give you discount. It's a scam, telling you now. Classes are a scam. If the crew selects low, but the temperature demand cannot be satisfied, pack flow is automatically selected to normal. It will not go to high. Okay, so in case it's selected to low and you cannot supply that demand is not being able to be supplied, then what it does, it automatically goes to normal, but it'll never reach high. Okay, so it'll be like above normal, still on normal it cannot supply, it'll still be on normal, but it might increase its flow rate to like for momentarily it might reach 103% and then again come back. Okay, so it'll never go like bust it all the way to 120 this thing. Okay, at any point where one zone cannot be satisfied, ACSC, like any one of the zones, so you have three zones. Okay, you have cockpit, forward, aft. Okay, in case you're wondering what zones are, oh my god, forgot to tell you of these. Cockpit, forward and aft zones. So in case any one of these zones is not satisfied, okay, what it does is it tells the APU or the engine, okay, supply more bleed air. So how it'll tell the engine supply more bleed air? Like it'll just tell the engine supply more bleed air. The engine itself will start spooling up, or the APU will start spooling up. Spooling up means it will start rotating faster, okay, and it will produce more air. During cruise, the cabin crew can only control 2.5 degrees Celsius ahead or behind of the temperature which is set in the cockpit. Okay, now ACSC failure. So ACSC failure, when will it happen? ACSC failure happens in case both the lanes are failed. Okay, otherwise if both the lanes are failed, then it's complete failure. Okay, the trim air valve is shut, water pressure regulating valve is shut, uh, and then the other pack is only running the whole show. Okay, uh, temperature control is lost. You only have whatever temperature is producing. Okay, one lane failure, no effect. Second lane will take over. Both lanes failure, related pack lost, hot air pressure regulating valve and associated trim valve valves close. Both lanes of the same ACSC. ACM failure. ACM failure is compressor turbine, that failure. Okay, if that fails, the affected pack may be operated in heat exchanger mode. Bleed air enters primary heat exchanger, goes through the that bypass valve and then goes through out. Little air goes through the compressor, goes through the turbine and comes back out. Okay, ACM seizure reduces the pack flow. Obviously it's going to reduce the pack flow because there's a very small tube which is actually supplying the air and that compressor ka jitna bhi air is going through. Okay, hot air pressure regulating valve failure, failed open or failed close. This is one tricky one. Failed open, it doesn't matter. Trim air valves are still there. Trim air valves will do its job. It will maintain trim how much it needs. Failed closed, then you have lost supply to the trim air valve. Trim air valves all closed. Hot air pressure regulating valve is closed. Pack 1 controls cockpit temperature. Pack 2 controls cabin temperature. Now you all will ask, array per mixer unit is there in the middle. How is he controlled? Pack 1 usually controls most of the air that is going towards the cockpit. Pack 2 controls most of the air that is going towards the. There is still mixing going on. It's just that it's so much flow and so much air that will be there. You won't realize the difference. Okay. Now pack 2 again will control it to a mean temperature which is between these two knobs what you have selected. It will get a mean temperature and it will say okay, this is the average, because again mixing unit, trim air valves, all that is, the trim air valves are shut. How is it going to be able to mixing? Okay, so it says na tera na mera beech ka. Okay, now trim air valve failure, optimized temperature regulation is lost. Okay, this is it. We are done for today. You all have to do control and indicators. I hate that part. I don't think so I will be able to ever learn that part. Other questions which they ask, they'll ask you ECAM indicators, when do the warnings come and all that crap. They can ask you mixer unit, what all air comes to the mixer unit. They can ask you what else, hot air pressure regulating valve ka fault light when it comes. I don't know what to say, man. You've got to learn it because you get a job only after that. Anyways, yeah. Thanks guys.